Illustrative Math, Geometry, Unit 1, Lesson 2 is called Constructing Patterns. You will need a compass and a protractor for this lesson. So our goals today are I can write or follow directions using straight edge and compass moves to create a pattern or diagram. And I understand the importance of using precise language when doing constructions. So here's our warm-up. Here are two circles with centers A and B. Based on the diagram, explain how you know each statement is true. So the first one here says that the length of EA is equal to the length of segment EA is equal to the length of segment EB. So how do you know for sure? So EA is right here. We want to know if that's equal or congruent to EB. So, whoops, what did I do? So if I just take this and turn it and kind of trace it, you can kind of see if you have tracing paper at home, definitely kind of a cool little feature there, because you're probably not going to have the technology like I have here on this screen. You can definitely tell that they look congruent or equal in length. How do you know? Well, what I would say is, I would say this. I would say EA is a radius of circle A, and EB is a radius of circle B. They share radius AB, therefore the circles are congruent, thus making segment EA and segment EB congruent. Okay? How do we know triangle ABF is equilateral? So kind of the same idea there. We could kind of copy that and say we could say that the circles share radius AB. I'm going to say, instead of they, I'm going to say the circles A and B share radius AB. So therefore, the circles are congruent, which makes segments AB, BF, and AF all congruent because they are radii. And by the definition of equilateral triangle having three congruent sides, ABF is equilateral. Okay. How do we know AB is 1/3 of CD? So you can kind of tell AB. If I were to trace AB, you can kind of see, oh, whoops, I didn't want to do that. You can kind of tell, oh, CA, AB, BD, it's 3 really. So this is 1 out of 1, 2, 3. But let's put that into words. Let's say CA, AB, and BD are all radii on congruent circles. We established that above. And then we would say AB is 1 radius out of 3 congruent radii. Therefore, it is 1/3 the length. All right, how do we know CB is equal to DA? So again, they're congruent radii, so CB is CA plus AB, or maybe instead of is, I'm going to say equals, and DA is equal to BA plus BD. So CB and DA are essentially a length of two congruent radii. Therefore, they are the same length. Okay. All right. Let's see if we can follow some steps here. So this is back to that first goal. That warm-up was just kind of understanding that picture there and all that. But I can write or follow directions using straight edge and compass moves to create a pattern diagram. So we're going to do more of the follow in this exercise here. So, and instead of using my straight edge, I have this like tool here where I can just click here and I can make a straight edge, like straight line like that. It's going to be a little bit easier than me using this because I got to turn it and all that stuff. So you use your straight edge at home. I will use the compass here. But all right, create a line through A and B extending in both directions. Okay, so here we go. I'm going to use arrows because it says a line. I'm going to make this go up here a little bit. So there's that. Create a circle centered at A with radius AB. So I need to center it at A. I need to put the point at A and open the pencil up so that it goes to B. So there's centered at A, point at A, length AB or radius AB. So I open it up so that my pencil goes there, create that circle. Circle intersects with the line L in two places. So I didn't make this long enough. Now it doesn't intersect, but the arrow you can see means that it goes on forever. So I'm going to extend that line a little bit. Okay. Label intersection point to the right as C. So that would be to the right of A as C. So line L is right here. Here's my line L. So label intersection point to the right of A as C. So let's put this here. Call that C. Create a circle centered at B with radius BA. So I am going to leave my compass. I didn't open or make my compass wider or anything. So this already has the same length. So centered at B with radius BA. So there it is. This circle intersects with line P. Yeah, oh, I was supposed to label this line P. Sorry, that says it right there. Circle intersects with line P at A. Here's A, and one other point. Label a new intersection point as D. Okay, so there's my D. Create a circle centered at D with radius length BC. So BC, I need to readjust my compass because you can see that it's too wide. So there we go. There's BC length. So centered at D. New circle right there. This circle intersects with the circle centered at B in two places. So here's my circle centered at B, two places right here. Label the intersection to the right of B as E. So this point is E. Using a different colored pencil, create a line through B and E. Okay, so let's see here. Use blue. Oh, it's supposed to be blue. Let's see if I can do that. There we go. And I didn't put arrows on it. Let me put my arrows because it's a line. All right, so what we did was, it looks like I created a parallel line here. It looks like line BE is parallel to line L, or you could say line AC, okay? Looks like that's what these directions did for us, okay? So it's really important that, I didn't check them off as I went, but it's really important that you read them, maybe reread them, double check everything as you go, and take your time, all right? All right, let's see if we can follow another one. These are going to create a perpendicular bisector. So bisector means we cut a segment in half. Perpendicular means 90 degrees, okay? So perpendicular 90 degrees, bisector means you cut in half. All right, let's see here. Create a point and label point A. Create and label point B. Connect point A to B to create segment AB. Okay, there's that. Construct a circle centered at A with radius length AB. So we take our compass and we put the point at either A or B. Well, wait, centered at A. So we need the point at A, and we need the pencil at B. A little off. Real important that you're very accurate here. There we go. Length AB. So there's my circle centered at A with radius length AB. Centered at A, radius AB. You can see that there. Construct a circle centered at B with radius BA. So I move my point there. I don't have to remeasure it because I already know that my compass was set to the same length. So there's that. There's that. Label the intersection points as C and D. Doesn't really tell us which to put as C and which to put as D. Construct line CD. Make sure I got that top one. There we go. So line CD right here, line CD is the perpendicular bisector of segment AB. So perpendicular would mean that it formed a right angle, and bisect means that these two segments are congruent. I might maybe want to label that as M for midpoint. So essentially you're saying that segment AM is congruent, which means equal in length to segment MB. And you're basically saying any one of these four angles are 90 degrees. So we could say angle CMB is the one I marked right there, equals 90 degrees. Sometimes you'll see a little lowercase m. That means the measure of angle CMB equals 90 degrees. You might see it like that. I don't want to confuse you with that M, but that means the measure of. This is a lowercase m. This is a capital M for point M. Okay, cool. So following directions. All right, look at the diagram below and write directions to triple the length of segment AB. Assume that you started with just segment AB. So all we had was this segment right here, segment AB. That's what we started with on our paper. All the other stuff was addition added on. So what do we do here? Well, you can tell that they extend segment AB to make it a line. You can tell that we drew a circle centered at B with radius AB. We drew a circle centered at A with radius AB. Maybe mark this point where circle B intersects line AB. Maybe mark that as C. And then it looks like I drew a third circle centered at C with radius AB or BC. Okay. So let's take a look here at these directions that I put on here. So construct line AB. So again, we started with segment AB, extend it to make it a line. Construct a circle centered at A with radius AB. So here, I'll tell you what I'll do here. I'll go through the steps with the highlighter here so you can kind of see. So we started with AB. We make this into the line first. That's the first step. And then we make this circle here. This is the second step. See, obviously it's a terrible way to do it freehand. Then construct a circle centered at B with radius AB. So my third step would be this circle right here. Then you can see we got to make another circle at C. Construct a circle centered at C with radius AB, same radius, labeled intersection as D. Oh shoot, I didn't highlight that third step. Fourth step be this circle right here. And then it appears that segment AD is triple the length of AB because AB is congruent to BC, which is also congruent to CD, particularly because they share that radius BC. So they all have a length of AB. So it's basically like I took this segment here. See if I can draw that segment. And look at that. 1, 2, 3. So it's 1/3 of the whole segment. Okay, so it's tripled. Okay. All right, so back to our goals. Want to cycle back to them. I can write and follow directions using straight edge and compass moves to create a pattern or diagram. And I understand the importance of using precise language when doing constructions. Didn't really hit on this a lot, but you kind of probably noticed like you need, for circles, really important circles, you need a center point and a radius length. Very important, okay, to be precise. Okay, obviously lines, we need 2 points. You need to tell me which points to make the line. But those are really important things, and obviously you need to label intersection points. Okay, and then use the new letters that you've created. Okay. That's it for this lesson. I modified it a little bit. You might notice that it doesn't go exactly along with the textbook. I kind of cut some things that I thought were maybe a little confusing and not the best use of time, and added a few other things in there to kind of maximize this lesson. So hope you enjoyed it, and we'll see you on the next lesson. Thanks for watching.